Welcome back. Applied Physics Lecture Series, Quantum Mechanics, Lecture 7. Schrodinger's time independent wave equation, Heisenberg uncertainty principle, and Born interpretation of wave function. What is this Schrodinger's one-dimensional time independent wave equation? As I mentioned in the previous lectures, so whatever the problem which is related to the motion of microparticle, which is related to the micro world, we have to solve the problems with help of Schrodinger's wave equation. That's why Schrodinger's wave equation is called as a basic principle in quantum mechanics. So according to this Schrodinger's time independent wave equation, so Schrodinger describes the wave nature of a particle in the mathematical form, and it is known as Schrodinger's wave equation. So consider a plane wave which is moving along the positive x direction with velocity v. Then the equation can be written as y is equals to a sine 2 pi by lambda into x minus vt. Here a is the amplitude of the wave, y is the displacement of the particle along y direction, and x is the displacement along x-axis at any instant of time. Taking the first and second order derivatives with reference to the x on both sides. Why this type of differentiation is required? We have to convert a plane wave into complex wave notation in terms of quantum mechanics. Because in quantum mechanics, complex waves, de Broglie waves, or matter waves are existing. But here we are taking the plane wave equation. That's why there is a need for us to convert such a plane wave equation into the complex notation. So in order to get such a form, we have to derive the plane wave equation twice with respect to x on both sides. As a result of first order differentiation, dy by dx is equals to a cos 2 pi by lambda into x minus vt into 2 pi by lambda. Then making the second order differentiation with reference to x, d square y by dx square is equals to minus a 2 pi by lambda whole square sine 2 pi by lambda into x minus vt. So substitute the plane wave equation y in the original form in the above equation, we will get d square y by dx square plus 2 pi by lambda whole square into y is equals to 0. In the complex notation, the displacement y is replaced with the psi. That means any physical quantity which is not constant, which is varying continuously, that must be represented with only psi in quantum mechanics. And we have to include material particle. Material particle means mass of the particle must be included. That's why in place of lambda, we will substitute de Broglie expression for wavelength. So that is, in place of y, we have to write psi, and in place of lambda, we have to write h by mt. Therefore, the expression becomes d square psi by dx square plus 2 pi by lambda whole square into psi equals to 0. Then substitute h by mv in place of lambda. Then the equation becomes d square psi by dx square plus 4 pi square m square v square by h square into psi equals to 0. But for a moving particle, the total energy is nothing but its kinetic energy. The entire energy of a moving particle is nothing but its kinetic energy. Therefore, if we write total energy with E and kinetic energy with U and potential energy with V, therefore the total expression for energy is nothing but E is equals to U plus V. From that, kinetic energy U can be written as E minus V. And you know the expression for kinetic energy. Why you have to consider kinetic energy here? Because the particle is moving, therefore only kinetic energy is accountable with that. Therefore, kinetic energy U can be written as half mv square. Then multiply both sides with m. Therefore, it will become 2mu is equals to m square v square. Therefore, we can written as u is equals to e minus v, and in place of u, if we write 2m into e minus v is equals to m square v square. Substitute such a m square v square in the expression of d square psi by dx square plus 4 pi square m square v square by h square into psi equals to 0. In that expression, in place of m square v square, write down 2m into e minus v. As a result, we will get the equation as d square psi by dx square plus 4 pi square into 2m e minus v by h square into psi equals to 0. And the final expression becomes d square psi by dx square plus 8 pi square m into e minus v by h square into psi equals to 0. Here, m is mass of the particle like electron, is the total energy, v is the potential energy. Total energy minus potential energy gives kinetic energy. Therefore, this gives concrete proof for the particle is moving continuously. As a result, it is having kinetic energy. Therefore, the particle can behave like waves. This is the one-dimensional form of Schrodinger's time-independent wave equation. Similarly, if you write three-dimensional form of Schrodinger's time-independent wave equation, it is nothing but d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square m by h square into e minus v into psi equals to 0. So this can be written as del square psi plus 8 pi square m by h square e minus v into psi equals to 0. Here we know very well h is Planck's constant, m is mass of the particle, e is the total energy of the particle, and v is the potential energy of the particle. So in order to solve the problems related to the motion of micro objects, that is belongs to quantum mechanics, we have to use Schrodinger's time independent wave equation, which is known as basic principle in quantum mechanics. Then coming to the Heisenberg uncertainty principle. You know very well quantum mechanics deals with either probabilities or uncertainties. You can't able to predict the exact position of the particle and along which direction it is going to move. That's why always the initial state or position of the particle is in the form of uncertainty. Therefore, classically, the state of a particle can be defined by specifying its position and momentum at any given time t. At each instant, the position and momentum can be measured accurately. When an atomic particle is considered as a de Broglie wave packet, then such a type of accuracy is not possible. Why? Because if we consider the wave packet consists of a large collection of particles. Usually those are microparticles in nature. Therefore, if you mention the size of the wave packet, we are having only two alternatives. First one is size of the wave packet is big, and second one is size of the wave packet is small. With those two alternatives, a moving particle is equal to a wave group and having a group velocity. If the group is considered to be narrow, it is easier to locate its position, but it is very difficult to calculate velocity and momentum. Why? Because if the particle is present in a small group, then such a group is moving with huge velocity. So when the velocity is very, very high, the particle is moving very fastly. As a result, the group is also, the wave packet is also moving very fastly. That's why you can't able to find out the velocity of such a group or particle. As a result, if you don't know the value of velocity, you can't able to find out momentum. That's why if you consider the wave packet, which is made up of with particles in the form of a small group, we can able to identify only the position of the particle, but not the momentum. Therefore, there is always an uncertainty to find out the momentum of the particle. And the second alternative, if the group is wide, the momentum is measured very easily. Why? Because in such a large wave packet, so because of that heavy size, the particle is moving with small velocity or less velocity. Therefore, you can able to find out velocity very easily. Once you know the velocity, you can able to find out. Therefore, you can able to calculate momentum and its uncertainty. But within such a large group, you can't able to identify exactly where is the location of that particle. Therefore, position of the particle is not identified very easily. That's why you can't able to identify the uncertainty in the position. By combining these two alternatives, Heisenberg is a German scientist in the year 1927 gave the uncertainty principle, which states that the determination of exact position and momentum of a moving particle simultaneously is impossible. In other words, it is almost impossible to find out both the uncertainties in the position and momentum simultaneously. If delta x is the uncertainty in the measurement of position of a particle along x-axis and delta p is the uncertainty in the measurement of momentum, then the product of those two, that means both the uncertainties delta x and delta p is nearly equals to h. Or in other words, the equation can be written as delta x into delta p greater than or equals to h by 4 pi. Therefore, the exact statement of Heisenberg uncertainty principle is it is almost impossible to find out both the position and momentum cannot be measured with perfect accuracy. Then coming to the another topic in the same lecture, physical significance of the wave function, Born interpretation. According to this one, we are using same representation psi to represent both particle nature as well as wave nature. Because both are not possible simultaneously, and the particle is exhibiting its original character, that is particle nature, Psi is defined as probability of finding the particle at the specific location during the observable period of time. For the same particle, when it is exhibiting the wave nature, the same psi can be written as wave function. Therefore, the wave function has no direct physical significance as it is non-observable quantity. It is a complex quantity which connects with the particle nature and is associated with wave nature statistically. Therefore, the product of psi and psi star. What is this psi and psi star? Psi is nothing but a probability of finding the particle at the specific location. Psi star is nothing but its complex conjugate. If we take the product of those two, it will give a real and positive value, which is represented with modulus of psi square. This is called as a probability density function, which is also represented with P. If you multiply such a psi with its complex conjugate, we are getting probability of identifying a specific particle from point-like region to over a region or over location. That means we are extending the probability of finding the particle from some point-like region to over a location. And if we enclose this entire function in between the limits, integral minus infinite to plus infinite, modulus of psi square into dx dy dz. What is this dx dy dz? It is representing the volume element. You can able to find out the position of the particle when it is moving. It can be moved along any direction. Therefore, volume element d tau is nothing but dx dy dz. If it is equals to 1, the particle is present in the specific location. If it is equals to 0, the particle is not present at all. In that case, there is no need to obtain the solution. Therefore, finally, psi can be considered as a probability amplitude since it is used to find out the location of the particle. Thanks for watching.